Friends, welcome to my YouTube channel. Today I am going to discuss the cantilever beam where point load, UDL and UVL, all three loads will be there. This is the maximum possibilities to ask the question in the university exam. So draw the shear force and bending moment diagram for the given cantilever beam. So this diagram is given. So what is given here? Point load 6 kN, one UDL EF 3 kN, UVL 8 kN per meter, 3 meter length, 1 point load. So the given. So these problems, what we'll do now, first we'll draw this load diagram. Why we draw the load diagram? Generally we are not drawing because once we'll calculate the moment, so it will be easy for you. So load diagram, suppose sometimes now engineering mechanics and all, they'll ask find the support reaction. So support reactions, how we'll find total vertical force, horizontal force, like this will add, and moment you will take now, you can get the both support reactions. Okay, so load diagram, it will helpful to find the moment only. It will useful, or it will be helpful for you how to draw the how to calculate the moment. So just I am drawing for your understanding only. Okay, so lot of instance we have confusion. Find the bending moment diagram, bending moment calculations, that doing the wrong. So for that, I thought in these problems I will give the load diagram. So load diagram, see here, 6 kN point load. That means we'll convert all the load into point load. This is the cantilever beam for A. So this is now new diagram I am drawing. This is 6 kN. 6 kN as it is. Now this is UDL. Now this is UVL, 1 meter here. Then this is 4 meter, 1 point load is there. Point load as it is. Load diagram is all load will convert into point load only. Either UDL or UVL will convert into point load only. So see here, UDL, already what I told, again you will learn here. Each problems I am discussing this. If you are taking, this is suppose 6 kilonewton per meter, this is 4 meter, A and B is there. If you draw the load diagram, load diagrams will be where? Because if you see the deflection of this, deflections will be maximum in the middle point. That means where will the load will act? In the middle point. UDL load will act in the middle point, because if you see the deflections due to this load on the beam, so you will see the deflection in the middle point. Suppose this is 4 meter. I told this total length is 4 meter. So this will come 2 meter, 2 meter. That means load acting here. And then what is load? 6 into 4 load. So for this 6 kilonewton per meter, 4 meter UDL, how we convert it into load diagram? 2 into 2, 6 into 4. So similarly here, middle point. Take the here middle point will be the load. What is the load? 3 into 2. That will come into kilonewton only. 3 into 2. Then what is this distance? 1 meter. This distance also 1 meter. This distance already given 2 meter. Now this is 1 meter. Now UVL. How to convert the load in the UVL? You see here. UVL. One concept is there. Another concept, what is? Suppose UDL will be rectangular load. UDL is also known as rectangular load, like this they will give. So once you are taking the moment or making the load, so 6 into half distance. See, this is point is center of gravity point. So we calculate it because deflection is maximum. If UVL will be there, where will be the center of gravity point? Where will be the center of gravity point? We have to calculate. So we have one derivation in engineering mechanics, but one concept I will give here. This total length suppose will be H. H. This is exact triangle, right angle triangle. Now, where will be the center of gravity? Suppose, okay, it learn from this way. Suppose this is the triangle is there. This height is H, this breadth is B. So where will be the center of gravity point for this? So center of gravity, generally entire triangle weight will act at a particular point. That means where the entire body will act. So generally near somewhere here will act. Center, it will be smaller cross section, center of gravity will not be there because area is here big, so center of gravity point will be somewhere here. How will know? So that for that derivation is there. Centroidal axis, where will the axis, where the center of gravity? So if we'll see from the bottom, will be the, if we'll see the from the bottom, it will become h by 3 only. If we'll see the top, it will come 2h by 3 only. 2h by 3. That means this distance from here to here, if you are traveling, you have to travel 2h by 3 distance. Once you are traveling from bottom to here, you have to travel h by 3. How you will remember? Suppose h you take 6 meter. H you taken 6, substitute both here. 2 into 6 by 3, how much will come? 4 meter. Now h by 3, 6 by 3, 2 meter. That means if you are traveling here, from here to center of gravity point, you are traveling more distance, 4. Here traveling not 2. So suppose what confusion will come? Either you will take bottom h by 3 or top h by 3. So for that confusion, just you assume 6 meter, calculate this, see this 4 meter means this longer distance. That means lower cross sections if you are traveling will be 2h by 3. Bigger cross sections you are traveling h by 3. So see this, like you can remember. So 2h by 3, h by 3. If both you will add 2h by 3 plus h by 3, you will add now, how much will come? 3h. So h only. So total height h will come. So that means center of gravity distance from the base h by 3, from the apex or top from 2h by 3. So now see here, apex, lower cross section. So from here 2h by 3. From this side if you will see h by 3. Similarly, if you want to come this distance again, so this distance again is bigger, so 2b by 3. If you will come from this side, it will be b by 3. It will be b by 3. So from here you will see this length b by 3. From here b by 3. So now from here and here we reach the center of gravity point. We reach now. So how reach here? This length is h by 3. This length is 2h by 3. This length is 2 by 3. This length is b by 3. Okay. So this way we can draw the load diagram here. How will convert the load of the triangle? Area of the triangle is nothing but load. This is the b. So b into h. Area of the triangle. Area of the triangle is nothing but load. Will convert into load. So first we are converting load here. How much load will come this one? How much load will be there this? 1 by 2 into 3 into 8. 3 into 8. This is load. So what will be there? 4. So 12. Where will be this? We are going this way. So this way how much? 3 is there, no? So we write here 2 into 3 by 3. So 2 meter. So 2 meter from here. This is 1 meter because total distance is 3 meter. So what is the point load here now? 1 by 2 into 3 into 8. I am writing one time here. 1 by 2 into 3 into 8 is nothing but 12. 12 kilonewton. This is the load. So the load diagram's over. So now this is, suppose this confusing, na, these things we can little clean it. Clean it. Now this is the new load diagram scheme. What is coming here? Load diagram scheme. One load here, all point load. Why we did this now? Only for moment you will get the helpful. For the moment you will get the, you will feel the easy. So for solving this question, see how much basic things you have to remember. Then only you can solve these questions. Okay. So this how to reach the center of gravity point, I told UDL how will reach the center of gravity point and what is the direction. Suppose this is there this way, so 2h by 3. Here this way, so lower cross sections 2h by 3. Lower cross section 2h by 3. If that also you will forget, take the height, some length, I assume 6 meter. 2h by 3 is coming 4. And then h by 3 is coming 2. So this is 2, this is 4 because bigger distance is 4, lower distance is 2. This way you can remember. Okay, these are the basic concept. Now we can solve now these questions. Okay, so these things, once you are seeing this video, all those things you write in the side some your notes book and keep ready for the any future, any type of another problems also. Okay, this will be basic, always will be helpful for you. Okay, so okay, now I will start the solution. So share force calculations for. shear force diagram calculation. So shear force at B. So B. What is the sign conventions I used to take generally? You see here, take one section, downward force will be positive. If you are considering right side, if you are considering left side, positive. So this you remember. So now right side, I am taking right side. So shear force 10 kilonewton, because at point B, load is there 10 kilonewton. So shear force at B, at point B, this is point B, this is C, this is D, this is E, this is F. This is all the point I given, okay? So 10 kilonewton, SB. SC, between C and B no load, so same 10 kilonewton. Same 10 kilonewton will be there, okay? Now, SD, shear force at D. Shear force na, you have to add the force only. So up to C how much came? 10. 10. Now this load, what is the load? 1 by 2 into 3 into 3 into 8. So 12. 12. So how much is coming? 22 kilonewton. How much is coming? 22 kilonewtons. Okay. Now look here. SD over SE. Shear force at E. No load in between D and E. So same things will come. 22 kilonewton as it is at root. Now come the shear force at F. Shear force at F. So up to E how much? Up to E point 22. Right as it is. Plus this only. So this load again you calculate. 3 into 2 load. 6, no? If your UDL is there, UDL value per unit length into length. So 3 into 2. So write one time. 3 into 2. This is load. So 6, 28 kilonewton. What is this one? Shear force at F. Now shear force at one more thing you remember here. Shear force at F, R will write here. R. Then will be 28. Why R and L? Left I am writing. Suppose shear force at here you see. Now shear force at L. What is meaning of R? Just before this point I am calculating shear force. Just before. आपके right side. आपके left side ना that point load also will consider. So 28 plus 6. So 34. 28 2 30 4 34 kilonewton. 34 kilonewton S and L. So S, R and L, why we are taking? Suppose UDL and point load will be there in the same point. So this point load means acting at point F, exact F. But both will be done, how you will calculate? R na just before this point. So we consider only UDL. But L na I consider point load also. Okay. So this is the concept between R and L. Okay. So now SA. No load between A and F. So same shear force will come 30 Newton, 34 kilonewton. So 34 kilonewtons, this will be the final shear force diagrams. Okay, now I will draw the shear force diagram. So these things I will rub it now because already you copied. So now we'll go the shear force diagram. Main part is here, how to draw the shear force diagram. Okay, so now extend this line and all. Extend this line and also shear force diagram will be looks clear. All the point you draw this dotted line or thin line where this point here, no? This and all you'll draw. Then here middle point is there, that not required. Once you're drawing the shear force, no? So that point load will not consider. So we'll draw the zero line here. Zero shear force line will draw first. This is called zero. Shear force line, shear force will be zero in this line. So point B. What is point B? As 10 kilonewton. So positive. So we'll go the vertical line. In between no load. So horizontal line. In between no load. So horizontal line. This is called point B, this is point C. How much? 10 kilonewton, 10. Okay. Now look here. I told already, here something I will draw. What is the line? Point load. Point load, horizontal line. UDL, UDL will be inclined line for shear force. UVL will be the curve line. UVL will be the curve line. This you have to remember. This is the horizontal line for point load. We'll write another color now, it will be easy for you. Point load means, things you can show the diagram itself, horizontal line. Then UDL will be inclined line. UVL will be parabola line. So this you have to draw in the shear force diagram. So now look here. I will draw here at point D. So what will be there at point D? UVL is there. UVL will be there na. Suppose UDL will be the inclined line. So we'll draw the parabola line. We'll draw the parabola line, curve line up to this. What is this point? D. So shear force at D 22. D point is 22. Now in between no load. So draw the horizontal line. In between E and D no load. Again will be the UDL. Again will be this. UDL will be there. So what will be there here? Inclined line. Shear force will be the inclined line. Then here point load. So point load means what will happen? Sudden changes will be there. Then here no load. We'll draw this. So look here. This is 22. E point. E will be how much? E will be also 22 because horizontal line. Now this point F. F will be 34 will take. Here will take 28. Here 34. So see here, if this diagram will be like this value, if you know here, seeing this what you know here. So this point is discontinuity is there. Cutoff point will be there. So 28 is there. That means we are not considering point load here. Up to UDL only. Here point load and UDL see connected is there. But here see shear force what we are seeing. E to F. This point is F. E to F inclined line 28 only. See FR. That means just before this point. Now here sudden change will be there. Why? Because point load will be there. So 34. This point will be F. Here also this point will be F. But considering here point load. Here only UDL. Now this is point A. Now make this solid line. Make this solid line. Hatch this part. This is called shear force diagram for. So maximum this much question they can ask. This is called positive shear force diagram. So okay. So this is the shear force diagram for this given problem. Now we'll calculate the bending moment diagram. So bending moment diagram. So bending moment diagram calculation. So look at this. This is the maximum they can ask the question. Now bending moment again we'll ask here. So that point load now it will be useful for us. So bending moment MB will be 0 because taking moment about B in this point 10 km load is there but no distance. So 0. Now we'll take the MC. It will come clockwise. So here also you have to assume the sign convention. See clockwise negative. Anti-clockwise negative. This is called right side. This is called left side. This is called anti-clockwise moment. This is called clockwise moment. This is the sign conventions we obeyed. Okay. So this also you extend here line to draw the bending moment diagram or line, thin line you have to extend. Thin line, this part also will be there. Now here for UVL, yes, and this line will be there. Okay. So once you draw the 0 line, bending moment ke 0 line will draw. So carefully you have to keep the scale, pencil or different color you can use for the bending moment diagram also. Okay. So MC calculation. So due to the sign conventions, C point rotate 10 kilonewton into 4. So minus 10 into 4 minus 40 kilonewton meter. Minus 40 kilonewton meter. So write this black pen. So this MC over. Now MD. MD. Point D. Look at here. With point D here. This is the moment, no, this load diagram will helpful. So 10 into 4 plus 3, 7 plus 8, 4, 3, 7. 4 plus 3, 7. So minus first due to the sign convention, left side clockwise minus. Now what is 10 into total distance, how much? At point D. Now if don't look here, now look here na, D. 10 into 4 plus 3, 7. How easy this look. How it looks easy. Now this load 12. We are taking moment about D to 12 into 2 only. 12 into 2 only. So over. If you will see the moment here, D point, how will write 10 into 7, then load 1 by 2, 1 by 2 into 3 into 4 into 2h by 3, 2 into 3 by 3. Like this you have to write. I will show you. 12 into 2 came now directly here. D na 12 into 2. How easily? This is called UVL moment. Suppose you are directly, you will see from there na D point. What will write? 1 by 2 into 3 into 8. Then 2 into h by 3. 3 by 3. So how much is coming here? 3, 3 get cancelled. This 4. How much here? 12 into 2. How much coming? 12 into 2. If you are doing the point load, how simple. No need to write this part. No need to write this part. This part equal to this only. Why possible this? Because already we did the load diagram. So once you are calculating the moment, see this how easy this one. This rotate, point load rotate. Point load everyone knows. Okay. Or this part. If you directly you know 1 by 2 load into 2 into h by 3. The distance. Okay. So these things carefully watch. Which way you are convenient, you follow. Okay, so this MD unit, MD will be, how much MD value? I will write calculations is there with me. MD will be minus 94 kilonewton, minus 94 kilonewton meter. Okay, now look here. Next E. Bending moment at E. Negative you take first, then E. E point, no? So look the load here. These are the length, distance only. How many load? 1 and 2 load is there. In E, 1 and 2 load is there only. So 10 into total distance, how much? 4, 2, 6, 2, 8. 10 into 8, right? 10 into 8 over plus. Because already minus taken outside, na, everything should write in between plus only. So at E you are taking. At E, this load 10 into 8. Now here 12. 12 into 3. That's all. 12 into 3. If you will calculate this way, load diagram, it will be easy. Otherwise, again 10 into this, then 1 by 2, 1 by 2 into 3 into 8 plus 2, 1 plus 2h by 3. I will show how you will write for this 12 into 3. So see here. 1 by 2 into 3 into 8, then distance 1 plus 2 into 3 by 3. So how much is coming? See here. 4 into 3, 12. 12 into 2 plus 1, 3. Coming. So either write this part or 12 into 3. So see how easy if you are drawing the load diagram, 12 into 3, 12 into 3 coming at E point. Like this, now ME, MF, MA will take na this, it will vary. It will vary like this, okay? So each calculations also will be very simple, okay? So ME, what is the ME calculations? We got it here. 10 into 8, so 116 minus 116 kilonewton meter. So, okay, minus 116 kilonewton meter. Now MF, ME over MF. See this carefully again. How easy we'll do now. MF. Here MF. How many load? 1, 2, 3 only. So 10 into 4, 6, 7, 8, 9, 10. 1, 2, 3, 2, 5, 1, 6, 4, 10. 10. So what is 10 into 10? 10 into 10 distance at F. Total distance. Now this 12 into 2 plus 3, 5. 12 into 5 plus 12 into 5. See this. What is happening here? Here I wrote 12 into 2 for UVL. 12 into 3 UVL. See UVL how simple. It's simple I am writing now. Okay. Plus now you see MF over UDL UVL over. Now another load where at F we are taking now. So UDL only. 3 into 2. 3 into 2 load. And what is the distance? 1. That's all. So 1. Now close the bracket. This is called UDL. This is called UVL. This is also UVL. This is also UVL. How simply I am writing. If you are drawing the load diagram, how simple looks. Calculations also how simple. So F na 3 into 2 into 1. 3 into 2 load into distance 1. This 5. 12 into 5. This 10 into 10. So now this MF calculations will be minus. MF calculation will be minus 166 kilonewton meter. Unit will be kilonewton meter for this moment. Okay. Now MA last. So once you are calculating MA, everything will be understood here. Take the minus 10. 10 into total distance. 10 into total distance how much? 12. 4, 5, 2, 7, 8, 9, 10, 12. 12, 10 into 12. 10 into 12 plus. Everything's plus because of negative I taken. Now 10 into 12. Now this 12 into 2, 4, 3, 7. 12 into 7. This is for UVL. You see here. Plus. What is this one? 3 into 2, 6. So right here 3 into 2. That's all. And distance is 3. Then what is this load? Point load 6 into 2. See this how easily we do. This is for UDL moment. UDL, UVL, UVL. All are UVL moment. So how looks simple? What is the calculations for this? Final answer will be minus 234 kilonewton meter. This is the calculation. Okay. So this way, if you will solve this question, all the process, it will go 2 page. Now see, looks 1 page problems we solve. That much big problem. This problem is not so easy. It is not so easy concept. Okay. But I made this how much simple. Now you draw the moment diagram. So this point is 0. Now point load inclined line. What is this line? MC 40. So inclined line you draw. Next UVL. UVL now what will be there? See here. For point load inclined line. Point load inclined line. UVL, UDL, parabola, cubic parabola, second degree parabola. This is cubic parabola, UVL. So now UVL is there, cubic parabola. So little draw cubic, more taper, 3 degree equation, cubic parabola. For C, this is for D. Now here no load, so inclined line only. Then again UDL. UDL means light taper, parabola. This is parabola. This is cubic parabola. This is cubic parabola here. Now this again point load and this no load, so inclined line. Inclined line, this is not curve line, this is called inclined line. Draw the by scale and all you have to use. So this will be the inclined line. This will be the inclined line A, F, E, D, C. So this way we can draw the bending moment diagram. If you this problem you are able to understand, that means you can solve any type of question. If you solve the any type of questions, okay. Students, watch this video carefully. All the basic here, lot of basic things I discuss. These problems carefully watch. Make the notes in your notebook. Then only you will understand. Okay. And subscribe the channel. Share this video to your friends. Okay. This very good problem and very good concept I given. Less time how to solve, that only will be there. Okay. Students. Thank you.